I guess the really important question here is, what is insulin resistance? And can you explain this to me like I'm a 10-year-old?
Oh yeah, for sure. Insulin resistance it's a disorder that has two parts. It's like a coin with two sides, that as much as we think of one side just because we hear the word insulin resistance, but there's another part to it that is very important. So insulin, first of all, is a hormone that we make from the pancreas, a long kind of gland tucked underneath the stomach. And the pancreas is a very busy organ. It makes a lot of different hormones. It makes hormones that come into the blood. It also makes enzymes that go into the intestines to help digest food. But among the hormones that are being released into the blood is insulin. Now, in the person with type 1 diabetes, their immune system has destroyed their beta cells. So they don't make insulin anymore. That's why for a person with type 1 diabetes, insulin is a life-saving therapy. You're giving them what they're not making anymore. But for everybody else, we have beta cells and they're releasing insulin when they need to. Now, usually the main reason the beta cell is releasing the insulin is because blood glucose levels go up.
So I eat sugar.
You eat sugar, or not even something as obvious as sugar, but bread or crackers,
White rice.
chips. Oh, yes. So basically anything that falls into the family of a carbohydrate. So if the earth grows it, that's a carbohydrate. If it's a plant, it's a carbohydrate. Maybe that's a better way of describing it. And so it's going to have starches and sugars, which all is kind of falls into this family of carbohydrate. Depending on how much starch or sugars that it has, then that will result in a bigger or smaller blood glucose or blood sugar response. But then if blood sugar is too high for too long, that becomes very harmful to the body. So insulin comes in and helps lower the blood glucose. And then having done its job, insulin comes back down.
So insulin comes out like a taxi and transports all the glucose in my blood to various places around the body to store them?
Perfect.
So
Yeah,
it's
and
like
the
a
main
taxi.
that's right. You can look at it's a shuttle, it's a taxi saying, "Hey, glucose, come on in. I'm dropping you off at the muscle." So mostly, just as an interesting tangent of insulin, before I finish answering insulin resistance, insulin will open the doors for blood sugar to come in and drive the taxi in, mostly at the muscle and the fat. Muscle and fat tissue need insulin to come and bring the sugar in via taxi. However, other tissues, and the brain a little bit as well, other tissues will still respond to insulin, but they don't need insulin to tell it what to do with the sugar. It just takes it in. But even on those, like the liver, for example, if the liver sees sugar driving by in the taxi, it just opens the doors and lets it in. It doesn't need insulin to come and tell it to let the sugar in. However, even at the liver, and every other cell has a similar degree of this, the liver doesn't know what to do with it. So this is back to something I'd mentioned earlier, where insulin's thematic effect at the entire body is to tell the body what to do with energy in all of its forms as these kind of caloric-rich molecules, what to do with lactate, what to do with ketones, what to do with fats or glucose, what to do with amino acids. So insulin will tell the body what to do with all of those things. But again, its most famous effect is to control blood sugar. And that's not wrong, because its most powerful activator is blood sugar. So with all of that in mind, insulin resistance is two problems wrapped into one. The one problem is the most obvious one, which is that insulin isn't working as well as it used to. So back to the analogy of the taxis dropping off sugar, if the muscle tissue has become insulin resistant, insulin is coming and trying to pull the sugar-loaded taxi into the muscle, but the muscle's not listening.
So say that again. So the
Yeah.
insulin's coming past with the glucose inside it.
Well, not technically. Yeah, but just to sort of go with your metaphor, but maybe to use another one, insulin comes and knocks on the doors. It's like the bouncer at the door. It's coming and knocking on the door of the muscle saying, "Hey, muscle, I've got some sugar that wants to come in." And normally the muscle will say, "Oh yeah, sure, okay, open it up the doors and let the sugar come in." When the muscle is insulin resistant, the bouncer's knocking. Maybe there's even, I'm almost getting ahead of myself, but one bouncer, maybe two or three bouncers pounding on the doors of the muscle cell, but the muscle cell's not listening. It's become deaf. That's the insulin resistance of what we call insulin resistance, where some of insulin's effects like helping lower blood sugar, it's not working very well anymore. And the muscle is just an obvious example because there's so much of it. It is the biggest tissue on the average individual. Someone who's very obese perhaps now has more fat tissue, but even people who are overweight, most of us is muscle. So it's a good tissue to look at. So part of insulin resistance is that of all the things insulin's trying to do, including lower blood sugar, it doesn't do it quite as well as it used to. Some of the cells or tissues of the body have become deaf to insulin's demands. Now, however, at the same time that's happening, insulin levels are higher. And that is really important. And I'll mention an example in just a moment that highlights the difference between the two. But we have to consider anytime we talk about insulin resistance, we think of two things happening in concert. One, insulin isn't working quite as well as it used to in various places of the body. At the same time, insulin levels are higher. And that kind of takes us back to the muscle cell where I'd mentioned, getting a little ahead of myself, that a bouncer is knocking on the door. And once upon a time, the muscle cell would hear that one polite knock from that one bouncer, or one molecule of insulin, if you will, and it would open the door and let the glucose or the blood sugar come in. But now the muscle cell, the bouncer, insulin's knocking on the door, but the muscle doesn't listen. It's resistant. And so the body has adapted and it learns, okay, well, if one bouncer wasn't enough, let's send an angry mob of bouncers. And then the muscle will start to open the door. And indeed it can. So those two problems go together. On one hand, insulin isn't working as well as it used to. That's what gives it the name insulin resistance. But there's another part that is equally present, which is that blood insulin levels are higher. Now, earlier at the outset of the conversation, I mentioned that even infertility has an origin, has some degree of development because of insulin resistance. And it's a perfect example of both of these parts of insulin resistance, where in some instances, insulin isn't working very well. Always with insulin resistance, blood insulin levels are higher. So for example, erectile dysfunction is the most common form of male infertility. In fact, its connection to insulin resistance is so strong that just a few years ago, I was so struck by a title of a paper that had just been published, which stated something like, is erectile dysfunction the earliest manifestation of insulin resistance in otherwise young, healthy men? Now, what is the connection? It's because in a normal erectile function, in order for the man to have normal erectile function, he has to experience a pretty dramatic increase in the size of the blood vessels in his body. The blood vessels expand, that increases blood flow, and then he has normal function. Part of that signal that tells the blood vessels that it's time to expand is actually insulin. And so this is what I said earlier, where insulin does so many things in the body, and we only think of it as being relevant to glucose, and that's not fair. Insulin does a lot of stuff, again, including telling blood vessels to expand. Now, unfortunately, in the case of this unfortunate man, his blood vessels become insulin resistant. So now it's insulin coming and knocking on the doors of the blood vessels saying, hey, it's time to expand and increase blood flow. But the blood vessels don't respond. They don't listen. So they stay constricted. Blood flow stays insufficient, and thus he has erectile dysfunction.